everyone. Today, we will learn step-by-step SPSS data analysis with a statistical test between group one-way ANOVA test. Learning the statistical test without knowing its functions in research is meaningless. Therefore, we will learn the test with a research example and its data. From the research example, we will first state the research hypothesis and then analyze the data in SPSS step by step to test the hypothesis and finally report the results and findings. At the end of this video, there is an exercise and you can download the SPSS data for the exercise and practice your data analysis skill. Everything will be very simple and very easy to understand. So, let us start. The one-way ANOVA test is used to compare mean score from two or more independent groups. The following is an example research of data analysis using between group one-way ANOVA test. In this example, a researcher found from literature review that in a traditional research, Mann in 1953 reported that the peak period for creative product is at age of 30 to 39 years. He conducted a research to investigate whether there are differences in creativity between three age groups, which are age 20 to 29, 30 to 39, and 40 to 49. The respondents are 103 students randomly selected from a business faculty student population of a university. In this research, the research design is a causal-comparative design. In this causal-comparative design, there are two variables, the independent variable age and the dependent variable creativity. Age is a grouping variable and creativity is a continuous skill variable. The objective of this research is to compare creativity between the three age groups. The research question is, are there any differences in creativity between the three age groups? Age and creativity are connected with a single-headed arrow to show the cause and effect between the two variables. This means age is a factor that is predicted influencing creativity of the student. The two variables in the rectangles and the single-headed arrow form a conceptual framework of this causal-comparative design research. In data collection, the researcher selects randomly a research sample consists of 103 students from the business faculty student population of a university. By using a creativity test, he collects creativity score from the research sample. For the age variable, student age 20 to 29 is labeled as group 1, age 30 to 39 is labeled as group 2, and age 40 to 49 is labeled as group 3. We will use this data for data analysis in SPSS. Before analyzing the data, the researcher needs to state the research hypothesis for hypothesis testing. In this research, the null hypothesis is there are no significant differences in creativity between the three groups. The research hypothesis is there are significant differences in creativity between the three groups. In hypothesis testing, if the p-value of the ANOVA test is larger or equals to 0.05, the null hypothesis is true, and we will report that there are no significant differences in creativity between the three age groups. However, if the ANOVA test results show that the p-value is smaller than 0.05, then the research hypothesis is true. We will reject the null hypothesis and report that there are significant differences in creativity between the three age groups. This concept must be very clear before we analyze the data in SPSS. The assumptions of one-way ANOVA test are the groups are independent. The second assumption is the independent variable is a grouping variable and the dependent variable is a continuous skew data. The third assumption is each group is normally distributed. And the fourth assumption is variances of the groups are equal. Before we analyze the data, we should run a preliminary data analysis to check the assumption 3, which is the normality of the data. The data is normally distributed if the skewness and kurtosis value of the data are in the range of negative 1.96 to positive 1.96. For the assumptions 4, the test of homogeneity of variance table in the ANOVA analysis output will show whether the variances of the groups are equal. To analyze the data in SPSS, we can put the data in Microsoft Word at the left side and the SPSS data editor at the right side. In this research, we have two variables, the independent variable age and the dependent variable's creativity. Before entering the data into SPSS, we need to label the two variables in the variable view in SPSS. To do this, click the variable view button at the bottom. Then, type the two variables names at the name column. Age, creativity. A single word is only allowed for each variable in the name column. Then, type the full name of the variable in the label columns. We can highlight the two variable name. In the name column, right-click, copy, and then highlight the two rows in the label column. Then, right-click and paste them. For age, it has three groups, so we need to label the groups in the value column. Click the right side of the cell, type 1 for age 20 to 29, and click the age button to move it into the box under it. Then type 2 for 30 to 39. Click the button 8 to move it into the box. Then type 3 for 40 to 49. And click the button 8. Then click the button OK to complete labeling the three age groups. So we can see the three age groups. There is no need to label creativity for the values because this is a skills data in score. So we just leave it none. Then we move to the measure column. Age is a grouping variable in ordinal skill data. So we click and select ordinal. And creativity is measured in score. So it is a skill data. So we click skill for creativity. For the other column, for this data, they are optional. We can leave them without labeling them. With this, we have complete labeling the two variables in the variable views. To enter the data into the SPSS, click the data view button at the bottom. In the Microsoft Word table, highlight the data of the two variables. Right-click and select copy. Then return to the SPSS data view. Click the first cell, right-click and select paste to paste the data into the SPSS. Now the data is ready for analysis.